Okay, we're going to skip a couple of sections here because there's two sections we're going to skip. The reason why is because they're pretty difficult, and you guys are going to need to be a little bit more focused. I think maybe after Christmas would be a much better time to cover the two toughest sections. So this last section is pretty, well, it's easier than the other two. Okay, and this is section 6.7. All right, it's the last section in this chapter. Your midterm exam, by the way, is going to be over the first 6 chapters. All right. Okay, this has to do with graphing, and we should, at this time, everybody should know how to graph. If we had an equation that looked like y is equal to 3x minus 5. Okay, Mario, what can you tell me about the equation of that, or the graph of that equation? What can you tell me about that?
Positive.
What's positive?
Linear.
It's linear. Okay, so when we graph it, we're going to get a straight line. What else can you tell me? The y-intercept is negative 5. Okay, so we're going to go to our y-axis. I'm going to put a point on negative 5. Okay? And what else do you know, Zach? Slope is 3 over 1. Okay, what does that mean?
3 over 1.
From where?
From negative 5.
All right, from negative 5, we're going to go up 3 and over 1, and I'll make another point. Is that enough points to draw a straight line?
Yes.
Yes, it is. Okay, I could go up 3 again and over 1. Up 3 over 1. All right. Now, we draw a line. Okay, so, and I think we can all do that. If we have an equation like this, that's its slope-intercept form, the graphing is fairly easy to do. All right, now we're going to change it just a little bit, because instead of y equals 3x minus 5, this is going to be y is greater than or equal to 3x minus 5. All right? So what do you think happens? And I don't know what you guys, if you've done anything like this in middle school or not.
You divide by y.
No, you're done with that, with the line part of it. Does anybody know what the greater than or equal to, what that graph is going to look like? Yeah, Aaron.
I have a guess, but the bottom part of the arrow that's pointing down, you can get rid of that part.
No, it's a good guess. It's not right, but anybody? Okay, so you guys haven't had this before. Well, what this involves is shading. There are a lot of values that will work. For instance, let's take this point. Let's take the origin, 0, 0. Let's see if that's true for this equation. In other words, I'm going to put in 0 for x, and I'm going to put in 0 for y. And let's see if that's true. 0 is greater than or equal to 3 times 0 is 0. What is 0 minus 5? Negative 5. Is 0 greater than or equal to negative 5? Yes. You've got two sides of this line. If one point works, if it's true, then that means all of these points over here above this line work. And so it involves shading, and we can show our shading on the graphs this way. All right? So it means that all the values that where these other lines are up here, where the shading occurs, all these values work. You can pick any value you want, put it in for x and y, and it will work. Yes?
If it was
side?
That is absolutely correct. If it was less than 3x minus 5, it would be on the other side. So what I want you to do is graph these straight lines, pick a point, and I think the easiest point to pick is 0, 0, and see if they work.
Will you do another one?
Well, I'll do a couple. Okay, does everybody understand that? Yes, Shannon.
How do you know that all the points on that side are different?
Well, you could test them all.
Like why didn't you shade the right side? Like
Why didn't I shade below the line? Let's give me a point over here below the line. Any point at all. 4, negative 2. Okay, let's try that point 4, negative 2. We'll see if that works. I'm going to put in 4 for x. Oops, it's negative 5. And negative 2. 3 times 4 is 12. 12 minus 5 is 7. Is negative 2 greater than 7? No, it's not, so it won't work. All right? So we just know, and if you pick any point above this line, or to the left of this line, it will work. All right? So we'll try a couple more of these problems. All right, we'll bring up a graph here. All right, and now I'm going to graph y is less than, let's say, negative 2/3 x plus 3. Okay? Notice it's not less than or equal to. It's just less than. Right. So Max, where does this line cross the y-axis?
What axis?
Where does this graph cross the y-axis? At 3. Okay, so I can put a point at 3. And what's my slope? Negative 2/3. What does that mean? I go down 2 and over 3, and I make another point. And that's where my line's going to be between those 2 points. Now, it doesn't equal. It's not less than or equal to. Well, if it doesn't equal that line, then what we're going to do is we're going to put a dashed line. It's going to be a dashed line, not solid, because it can't equal that line. So the question becomes, do I shade above the line or below the line? And the easiest point to pick is 0, 0. If it works, if 0, 0 works, I'm going to shade below this line. If it doesn't work, I'm going to shade above the line. So let's see. I'm going to put in 0 for x, and I'm going to put in a 0 for y, and we're going to see if it works. Bless you. 0 is less than. Negative 2/3 times 0 is? 0 plus 3? Is 0 less than 3? No. That means that when I plugged in this point here below the line, oh, 0 is less than 3. Oh, that'll sound good on the website. Yeah, 0 is less than 3, so it works. So it works. That means all these numbers will work. And that's how we show shading. Okay? Yeah, I don't know what I was thinking. Must be Christmas time. All right?
Joseph?
Yes.
Last time, like the other graph you did, it worked and you shaded above the line.
And the reason I shaded above the line, that's a good question. The reason I shaded above the line is because this was y is greater than. And the graph that I just did, y was less than. So it's below the line.
So if it's less than, it's always below.
Pretty much, yes. If it's
Unless
less than,
it doesn't work.
if it's less than, yeah, if it's less than, it's going to be below the line. If it's greater than, it's going to be above the line. Yes.
So if it's less than or greater than, it'll be a dotted line, and if it's less than equal to or greater than equal to, it'll be like a solid line.
That's correct. In other words, what Emily just said, if we have a less than sign or a greater than sign, we have, and I think the book uses dashed. There'll be a dashed line or dotted line, however you want to think of that. If it is less than or equal to, greater than or equal to, then we have a solid line. Okay? Would you agree? Yes, Zach?
Could the equation be like flipped though? Like it climbs on the right?
Yes.
So then you can't take it backward?
You know what? And I'm going to tell you this, and let me get another screen here. If I had so you're saying if the y was on the right side, I would reverse everything because I think it's easier to understand, and I'm going to tell you to do that. Right. Let's take another equation here. Let's take 3x minus 5y is less than or equal to 20. Okay? And I'm going to ask you to graph that. The easiest way to graph it is to put it in slope-intercept form. Y is less than or y is greater than. Okay? Well, I've got all the things to the left of there, so what I'm going to do is I'm going to subtract 3x from here, 3x from both sides of the equation to put it in slope-intercept form. You know how to do that. What I'm left with is negative 5y less than or equal to negative 3x plus 20. And I put the x first so I could put it in the slope-intercept form. And now what do?
Divide by -5.
Divide by negative 5. So I'll divide this by negative 5. Yeah, watch. I'm going to divide this by negative 5. I'm going to divide this by negative 5. You have to divide all three. Okay? So that here I'm going to have y, negative 5 over negative 5. Over here, a negative divided by a negative is a positive, so this will be positive 3/5 x. And 20 divided by negative 5 is negative 4. And what about the sign?
Flip it.
You have to flip the sign. So it's going to be greater than or equal to. And that's a much easier equation to graph. It's going to cross the y-axis at negative 4. My slope is 3/5. That means I'm going to go up 3 and over 5. And I'll put another point here. Is it going to be a solid line or is it going to be a dotted line?
Solid.
Solid, because it could equal. Now let's do the shortcut that I was talking with Zach about, I think. Zach, you think I'm going to shade above the line or below the line? Above the line because it's greater than. And that's true. If you are not sure, you could plug in the origin, plug in a point, see if it works. In fact, on your homework tonight, some of the problems are going to say, does this point work? Is it part of the solution? And you just plug points in. And then you'll have a few where you have to graph. So let's plug in 0 for x and 0 for y. And we're going to see if it's true. Yes?
If the sign is greater than, will it always be above, or could not necessarily? So you always know, or?
You always know, yes.
So why would you have to do that then?
Well, what I said was that if you're not sure,
But how would you not be sure if it's always, like,
No, I
that's
see the point.
If you're not sure, okay?
You forget. Just
Well,
when in doubt, write
I
it
don't
out.
understand.
when in doubt, okay? And this always works. It always picking a point, it always works. Okay? So I'd have 0 greater than or equal to 0 minus 4. And 0 is greater than -4. So it works. So all your shading occurs above the line. Okay? Does that make sense, everybody? Right. Okay, and this is the first part of section 6.7. Your homework for tonight.
If you want to give me the student picture, the student picture. Yes, I do.
Your homework's going to be on page 409. How much do you really want to have?
Tiny bit.
Then I wouldn't say much if I were you guys.
5 or 6 probably.
Because if we really want a lot.
No, we don't.
Give us a lot.
Thank you.
35. That's it. That's it.
3 through 35 odd.
Oh, I didn't take it.